far, this chapter has been pretty tedious, a lot of multiplying of stuff out. There are some tricks that now that we have a little bit of experience under us, there's tricks for a binomial squared and tricks for something on the back side that we call conjugates. We're going to discover this trick by probably the third problem. You know, after doing 3 of them, there are 15 of them on this side. It looks like we have a lot of work. It is not a lot of work once you learn the trick. So you see that this guy right here has 2 terms. That is known as a binomial, correct? And isn't it being squared, right? When you square something, that means take it times itself. So we've been crossing out that little squared and putting this same group of parentheses times itself. So let's multiply that guy out. So 3p times 3p is 9p squared. Then distribute in all the way out to this guy. That would be plus 12p. Then, done with him, start over, plus 12p, plus 16. There are some like terms to combine on that guy. So we get the final blue answer of 9p squared. Then we got to add 12p and 12p together and get 24p plus 16. That there is our final. Let's do that again. We got ourselves a binomial. It is being squared, so long way is to rewrite it to where we're going to take it times itself. Then we'll distribute. What's these first guys turn out to be when you multiply them together? What's 2h times 2h? 4h squared. Then we got to multiply. So get that 6h. Those are kind of called the outside guys. And we multiply the inside guys and get another 6h. And then we get the 3 times the 3 and get a 9. So 4h squared plus, how many h's were there, my friends? 12 h's plus 9. Yeah. Let's do that one more time, see if we can find the pattern. So m plus 5. This pattern is only going to work for a binomial squared when you take the same binomial times itself. So m times m is what? M squared. Then I'll bet you start seeing it. Even though it's Monday morning. So discuss with a neighbor. After only doing 3 of those, do you see some sort of pattern developing? We've noticed that the 2 middle guys are always the same. That's very obvious. In the next 3, let's see if we can figure out how we get this first guy and this last guy. So let's try it again. Let's do the long way. And I know that I should get like the 2 middle ones being the same, but what would end up happening to get the first one? Like, what if that wasn't there? Like, what would you have to do to get that first term? Isn't it a times a? Are you with me on that? It's a times a, right? Because if you wrote that group again, a times a, which is how much? A squared. And then you get like a times 3, which is 3a, plus another 3a. And then what would the last one turn out to be? I mean, we know it's 9, but like, where does it come from, right? Where do you get the 9 from? What times what? 3 times 3, right? You know, so we would have ourselves a 9. And then, of course, that would be a squared plus, how many a's would there be? 3a plus 3a is 6a plus 9 in that case. So like, let's see if we can, let's skip 5. It's kind of weird, right? You know, we'll come back to 5 and do 6. Could you do it without like writing the second group there? What would you have to do? I'll write the second group there, but think about it. What times what would be the first move? What times what? X times x, right? You know, what would that be? X squared. Then you'd have to like multiply these together, right? You'd have to distribute. Isn't it x times 8 and 8 times x? How could you see those without like writing that second group? Aren't those the two ingredients in the binomial? You have to take x times 8 and 8 times x. Are you with me on that? So you would get 8x plus 8x. And then what would be the very last term in that situation? You'd have to do 8 times what? 8 times 8, which is how much? 64. But what we're going to try to do is not have to write all 4 of those terms down. We can just get it to where we have the first guy, and then we know there's going to be like 2 8x's in a row, right? So like you'd end up adding those together and getting 16x plus 64. So here's the shortcut, right? The shortcut is that you do 3 moves. It's really 4 moves, but we do 3 moves if you want to go up top. The first move you do is you square the first guy. Like the first guy that I mean is like this dude in the parentheses right here. If I can grab my highlighter. Like you square that first guy. Then you take twice the product. It's been a while since we've mentioned the word product. Remember, like sum means addition, difference means subtraction, product means multiplication. You're going to do twice the product and then square the last guy. 3 moves. This dude right here, though, is actually got 2 moves in it, twice the product. And you'll see as we go through this, this will be much, 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 much faster. But it started off with some rough ones here. So we're going to come back to number 7. We're going to start with number 8. First question, is this a binomial squared? Yes or no? So here's our trick. Square the first guy. What would you get? X squared. Then this twice the product is the real challenge. Here's how I say we should do that in 2 moves. Move 1, multiply these together. What's 3y times x? And if you could try to maybe put the letters in alphabetical order also, like what would that turn out to be? 3xy. Are you with me on that? But won't that show up twice? Are you with me? You have 3xy and another 3xy. So 1, find the product. Now double it. What's 3xy times 2? 6xy. Are you with me on that one? And then the last move is square the last guy. We're going to take 3y and square him. What's 3y squared? It's 3y times 3y. Wouldn't it be 9y squared in that scenario? That's it, man. Square the first guy, twice the product, square the last guy. So let's go over to 9. Square the first guy. What's 2p squared? 4p squared. Then twice the product. Do it in 2 moves. First, multiply those guys together. What's 2p times 4r? Let's get the numbers. Wouldn't it be 8, and then we'd have a p and an r with it. That's the product. I need twice that because it's going to show up 2 times. So not 8pr, but 16pr. And then finally, square the last guy, 16r squared. Now let's go back and do number 7. I skipped him because he's got a little exponent on him on the inside. Who cares? Square the first guy. What's x squared? Squared turned out to be x to the 4th. Twice the product. I just need to get the product of those guys. So multiply them together. X squared times 1 is x squared. Double that. Is it x to the 4th or 2x squared? Yeah, be careful. It's 2x squared. And then square the last guy. Here's where our brain fart comes in. What's 1 squared, baby? Is it 1 or is it 2? It's 1. That's the shortcut for a binomial squared, baby. So let's try it again. This guy is a binomial squared. I'm going to talk you through the move. You do the move. Ready? Number 10. Square the first guy. X squared. Next, I need to multiply an x and not a 6, but a negative 6. Isn't that negative 6x? Double it, right? Double it. How do you feel about negative 12x? And then here's the other weird little thing. I need to square the last guy. What is a negative 6 squared? Is it 36 or negative 36? Positive 36. Cool. So I will have you pause the video and try number 11. So squared the first guy, then multiply those dudes together, then double it. So that's negative 20x times 2 is negative 40x, right? And then square the last guy, 25. And then just keep rolling. Square the first guy, twice the product, square the last guy. Square the first guy, twice the product, square the last guy. If you got 12 right, do 13, 14, and 15. Why don't you pause the video, get that done with a neighbor. So square in the first guy, 4x squared. The product of those is negative 16xy. I need twice that, so negative 32xy. And then square the last guy, 64y squared. Square in the first guy, m to the fourth. The product of those is negative 2m squared. I need twice that, so negative 4m squared. And then square the last guy. And then finally, what's x cubed squared going to be? Is it x to the fifth or x to the sixth? X to the sixth, because you're doing power to a power, you multiply the exponents. Minus 2x cubes plus 1. What do you think about the trick? Here's what happens. We're going to learn another trick on the backside. We'll get a little confused between the two tricks, and then as time passes, you will forget the trick. You know, it's like, forgot the trick. Worst case scenario, scratch him out, take him times himself, you'll never get it wrong. You know what I mean? It's like it's going to work, right? It's going to work if you take it times itself, especially down the road. But that trick only works for a binomial squared. Is this a binomial squared? What do you think, yes or no? It's freaking close, though. Would you believe? It's really, really close. What's the one little difference between those two parentheses? Do you see how one of them is a plus and one of them is a minus? Fancy word. You'll use it a lot as your algebra career goes. Those are called conjugates. I'd like us to say that once. They're called conjugates. What are they called? Where it's the exact same group, right, except for the sign in the middle is different. Let's learn the shortcut by going the long way. Let's multiply this out. Distribute in this first guy right here. X times x is x squared. And then x times 4 is a positive 4x. We're cool with distributing that first nugget through there. Then moving on to a negative 4, you get a negative 4x minus 16. Are there some like terms to combine? Cool. What does positive 4x and negative 4x add up to be? Nothing, right? Don't they add up to cancel out, right? So you're left with x squared minus 16. Neat. Let's try that again. Are these guys conjugates of each other? Yes or no? Are they the same group, but one of them is a plus and one of them is a minus? It doesn't matter where the plus and minus is. If the plus comes first, the minus comes second, or vice versa. It doesn't matter. They're the exact same group. It's a p and a 2, a p and a 2. One of them's got a plus, one of them's got a minus. So let's distribute. P times p, p squared. P times negative 2 minus 2p. Done with you, dog. Then plus 2p minus 4. Combine like terms, what happens? They add up to be nothing. Talk to a neighbor. Can you see all three ingredients? Like, what will be the trick on this one, I should say? What will be the trick? Yes, we know this. I think we're seeing this is going to happen. How do you get the other guys? Excuse me. You can check with the neighbor after each one. First times each other, last times each other. Macho Man. So we got m squared minus 25 on this one, first, last. 4d squared minus 9, first times each other, last times each other. 9 minus 25q squared, and x squared minus y squared. Then realize, are these special? This guy is. He is a binomial squared, so square the first guy, twice the product, square the last guy. Do all of them, man. Is number 26 special? Are those conjugates of each other? Nope. One of them is a t minus 3. The other one would have to be a t plus 3 for that to happen. Is it a binomial squared? In disguise, right? Isn't it the same thing times itself? So you can still do that shortcut. It's going to be square the first guy, twice the product, square the last guy. And then the last 27, is it special? I always check for conjugates first myself. You know, I think the conjugates one is easier, just first and last. So is number 27 conjugates? So first terms times each other, last terms times each other. And 28, also conjugates. Same group, one's a plus, one's a minus. First terms times each other, last dudes times each other. Is that it? Cool. Hey, work shown on homework. I think 0 on special, guys. Would you believe you could do all of these without showing any work? Does that make sense? That's the point. If they're not special, you probably better multiply them out, though. Does that kind of make sense? So if they are special, you can do them without work. How do you get better at the shortcut? Practice it.